Hello everyone, this is Carol. Welcome to my 6-minute presentation. This will be an overview of Turing Machine. This is my presentation outline. First, I will discuss the mechanism of Turing Machine, which was invented by Alan Turing in 1936. Second, I will briefly talk about who Alan Turing is. Finally, I conclude with the importance of Turing Machine in today's world. Let's first explore the mechanism of a Turing machine. Turing machine is essentially a mathematical model for computation. It consists of an infinite memory tape with smaller, discrete cells. On each of the cells, there is a symbol representing a bit of information. The tape is thus a string of information related to problems or languages. In addition to the tape, there is a head, which is a pointer to read tape inputs from the cells. The state register then stores, interprets, and proceeds the inputs. The machine then consults transition functions, which is a table of instruction. Once all the inputs are proceeded, the machine decides the next steps until it accepts the inputs. By accepting the inputs, it means that the process enters into a final state and outputs will be generated. Alternatively, the process will be rejected or it stays in the loop when the information is undecidable. This is a model of Turing machine. This is a tape, and this is the pointer or the head. This is a quote from Turing's 1948 report on the invention of this machine. He believes that it has an unlimited memory capacity obtained in the form of an infinite tape marked out into squares, on each of which a symbol could be printed. At any moment, there is one symbol in the machine. It is called the scanned symbol. The machine can alter the scanned symbol, and its behavior is in part determined by that symbol. But the symbols on the tape elsewhere do not affect the behavior of the machine. However, the tape can be moved back and forth through the machine, this being one of the elementary operations of the machine. Any symbol on the tape may therefore eventually have an inness. As we can see from the quote, Turing certainly envisioned later development of computer science. Here is a visualization of Turing machine. As you can see, this is the tape, the memory tape with the cells, and this represents the pointer or the head. The pointer or the head moves back and forth until the final stage. So the Turing machine is seen as an inspiration for later digital computers because it has a system of inputs and outputs, memory, and also central processing unit or CPU. This is an example of transition functions table. One can see that all the next steps are decided by the previous step. And these are the symbols used for the functioning of Turing machine. From these two images, we can see that the essence of computer science is the combination of algorithm and logic. Now let's move on to who Alan Turing is. Alan Turing was born in 1912. He is now remembered as an English mathematician, computer scientist, logician, cryptanalyst, philosopher, and theoretical biologist. Of course, he's believed as the father of theoretical computer science and artificial intelligence. Turing received a degree in mathematics from King's College, Cambridge University. During the Second World War, Turing was a significant figure for code breaking in the British government. He assisted the Allies to defeat the Axis powers through breaking coded messages, primarily from Germany. In spite of his contribution to the nation, he was unfortunately prosecuted for homosexual acts in 1952, because back then homosexuality was seen as illegal. In order to continue his research, Turing chose chemical castration treatment over being put into jail. And just 2 years after his prosecution, he was found dead, presumably because of cyanide poisoning. Without doubt, Turing had a tragic end in his life. But today, he is associated with extensive legacy. Here are just a few. In 2009, Turing received an official apology from then British Prime Minister Gordon Brown. Likewise, in 2013, Queen Elizabeth II presented a posthumous pardon to Turing and his family. Furthermore, the Alan Turing Law, which is an informal term for the Policing and Crime Act 2017, which is essentially an amnesty law to pardon males who were prosecuted for homosexuality in the British past. Since the passing of the law, Turing has been seen as an important symbol of defending LGBTQ rights in the UK and the rest of the world. For the wider public to commemorate his contribution to modern computer science, his portrait is currently on the £50 bill in the UK. Of course, one cannot ignore that the release of the 2014 film, The Imitation Game, was a theatrical success, and the film has been bringing global audience to the life story of this legendary intellectual. Here is an image comparing Benedict Cumberbatch, who portrayed Alan Turing in the film, and Alan Turing in his 20s. So some people even believed that Cumberbatch and Alan Turing are biologically related. In the final part of my presentation, let's look at the importance of Turing Machine on today's world. It helps numerous later computer scientists to test the limits of computation. The term Turing completeness describes if a programming language can express all tasks that could be achieved by computers. In other words, that's the highest level for the success of programming. Universal Turing Machine assumes that ultimately there's a machine that can tackle any computatable problems. And certainly, this is the foundation of computer science and the belief in having machine computers to replace human computers has dramatically changed human-machine interactions, and it has led to the progressing fields in artificial intelligence as well as in machine learning. So here's an image of a wooden model of Turing machine. One can see the simplicity and elegance of the model, but also one cannot ignore the complexity and the usefulness of its functions. This wraps up my 6-minute presentation. These are my image references. These are my overall references for the presentation. Thank you for listening. 拜拜。